So to see the different parts of an object, we're going to use an example, a running example of a bank account. And this particular bank account has a balance, and we're able to find out what that balance is, and we're also able to deposit money into the account. So it doesn't have all the features of a bank account, but it's enough for our purposes here. And we don't understand everything we see before us quite yet, but looking at it, we see some very familiar elements. For example, we see declarations. We see that the initial balance is an integer. We see that funds is an integer. So we see some familiar elements. Get balance looks like a method. In fact, it is a method. It just doesn't have the word static in front of it. And we see the familiar braces for packaging and scope. So even though there are some new things here, they're built out of some elements, at least, that are already familiar to us. So we're going to go through this a little bit. Let's take a look at the declaration. We see the balance is declared as an integer. That's familiar. Get balance and deposit are methods, and we've seen those sorts of things before, and the braces for scope. So what's new about this is the word private, which we see on this declaration of balance, and that'll be explained shortly. Some methods have no return type. We've never seen that before, but the account method here has no return type. And we don't see the use of the word static anyplace. So there are some real differences between this and what we've seen before, but much of it is familiar. And we're going to look at these, but it will be helpful to keep in mind what you already know about a bank account object. That is, the bank account you may have and the kinds of actions you may want to perform on those. So to begin with, let's talk about the name of an object, its type. And this particular object is entitled account. And so this specifies the name of the object type, and it's a style issue that object names always begin with an uppercase letter. That's just punctuation and form for defining object classes. There's no spaces or punctuation in the class name, but you're welcome to use camel casing. So for example, mouse listener might have a capital M and a capital L. And this name has to agree with the file name that you see in your development environment. In Java, the name of a type of a class, like account, is held inside a file called account.java. Now, the development environment we use manages all that automatically, but I'll point that out here just in case. The next thing we're going to look at is the constructor. And you see the constructor highlighted here. And how do you recognize a constructor? It has the same name for its method as the name of the type of the object. So if this is an account object, public class account is the type, then the constructor is always called account. There could be more than one constructor, but its method name, that part of its signature, is always the same name as the object type, namely account in this case. It can have parameters. For example, this one takes in an initial balance, but it has no return type. I'll talk more about its purpose shortly, but for now, just be satisfied that there won't be a return type declared there. And it's responsible in some sense for giving birth to an object. So if you want to make an account object, the method that gives birth to it is called the constructor, and this is such a constructor here. Inside the code of the constructor can be any statements we like. It's the principle of composition applies here. If statements, whiles, fors, assignment statements, anything you like. But in terms of purpose, the purpose of a constructor is almost always to initialize the instance variables. So how would you find an object's constructors if you were shown some code? You would look for the name of the object, and then find a method with the same name, and there could be more than one. For example, maybe we want one constructor that takes in an initial balance and provides the account with that balance initially, and another one that takes no initial balance but has some default initial amount in the account, perhaps 0 or perhaps some initial deposit the bank is willing to give you. Okay, the next thing to look at is an instance variable, which we see declared here. Instance variables, at least for now in our course, are usually declared private, and this is so they can only be accessed within a method. It's a form of encapsulation. And these instance variables live and are declared between the methods. They're not declared inside a method. This int balance statement here occurs outside of any method. And their values can persist after a method returns. We're not used to that. When a method returns, all of its local values go away, but these instance variables do persist. In the case of an account, that's a good thing. If you deposited money into an account, you would be surprised to find that after the deposit method returned that the money was gone. So it's important that these instance variables do persist. In terms of object design, if I'm telling you a story about an object, these instance variables are often called the hasas, that is has-a. has-as of object design, as in an account has a balance, a person has a height. And these stories can be directly translated almost always into instance variables wherever you hear the word has-a. Okay, so remember the constructor is supposed to initialize the instance variables, and so let's fill out our constructor here. Now that we have the instance variable balance, we'll set the balance equal to the initial balance provided to the account method, the account constructor, when the account is created. We'll see more about how this is created shortly. So this assignment statement that we see here initializes the instance variable balance. And the way to call this constructor is to say new account and then specify whatever information is needed inside the parentheses of the constructor. This particular constructor needs an integer, so if I call new account and pass it 100, the action is going to transmit 100 to the initial balance variable. The assignment statement evaluates the right-hand side to 100 and then assigns it into the instance variable balance. Now, instance variables retain their values, so when the constructor's over, the balance is still 100 and we're able to deposit or find out the balance of this account subsequently. So these references to instance variables can occur in any non-static method, and you see several references highlighted here. The instance variable is usually preceded by the word this, as in this.balance. And that's something different than what we've seen with local variables. For initial val, it's a local variable. We would not put this in front of it. But in front of an instance variable, for clarity, I'm always going to say this.balance. How do you find the instance variables of an object? They're declared outside of methods, usually at the very top of the code, as shown here. They almost always have the word private before them, and their references throughout the code usually begin with the word this. Okay, next let's take a look at a method that provides functionality for this object. So if you have a bank account, one of the things you might like to do with that is to find out what its balance is. So because of that design consideration, the person who developed the account object type would define a method called getBalance. It looks like the methods we've seen before. It has a return type. In this case, it's an int. It does not have the word static. GetBalance doesn't need any information because the information required to tell you your balance is contained inside the instance variable balance. So the code for getting balance is simply to return this.balance. This type of a method, which accesses an instance variable, is called an accessor, and more specifically, we call it a getter, because it gets the value of an instance variable. So if I make a call to get balance, it's going to return the current value of the instance variable. Let's suppose it has 100, and here we see a diagram of how that's going to work. The method gets called, this.balance, having 100 is substituted for this.balance, and then the return provides that result to whoever called it. Let's look at another method. This method, deposit, adds funds, the specified funds, to your bank account. So this method serves to deposit money into an account, and it does this by changing the value of the balance instance variable. Now we've incremented variables before. We could say I equal I plus 1 to change the value of I to be 1 greater. Here we're taking the instance variable balance, which records how much money you have. We're adding the specified funds provided as a parameter when this method is called, and we're storing the result in this.balance. So suppose the balance is currently 100, and we want to ask the account to deposit $50. 50 is transmitted into funds, which is then substitutable wherever we see the variable funds used. The sum of 150 is computed. 150 being the right-hand side value then gets stored in the left-hand side, which is this.balance, and once that's done, the balance in your account becomes $150. And that persists after the method returns, which is what you want. So in summary, what we see is the class name. Here it's account. Instance variables, these make up an object, constructors, and then methods. These 4 ingredients allow us to create classes that carry out whatever purpose we have designed for them.